Hello and welcome to this learning video. Here in this learning video, we are going to take the working rule and the example on inverse of a matrix by partitioning method. In the last learning video, we have seen how to get the partition of a matrix for a general matrix. We have talked about in general, but here in this learning video, we'll take the particular example and we'll follow the process to get the inverse of a matrix by partitioning method. Okay, so here you can see, as I said in the last learning video, that I am going to start with the working rule, which would be very handy in solving the problems. Okay, computation. So this working rule says you have to partition a given matrix in such a way that determinant of P is not equal to 0. Okay, that is P is a non-singular. So the very first thing that you can do when you are taking a problem on this inverse by partitioning method, you can do this thing, partition in such a way that P is non-singular. Okay, then the very second step is find out the inverse, because if P is non-singular, determinant is not 0, so its inverse exists. That's why you can find out P inverse by making use of this formula, adjoint of P upon determinant of P. Once you are done with this step number 2, find out T. T is any arbitrary matrix representing Rp inverse. Okay, so this Rp inverse you have to find out, and then with the help of this T you can find out W, Z. Okay, and after that you can find out Y, okay, and X. Now after you find out all these Z, W, Z, Y, X, you have to put all these values in this A inverse to get the desired inverse. Okay, now you may be wondering, like, a very lengthy process is there, but believe me, although it is a lengthy one, but if you are good at computation, you will like this topic. Okay, anyhow you have to, it is in our syllabus, so anyhow you have to learn the things. Okay, so let us take a problem on this to make the ideas more clear. So example number 1, find inverse of, example, find inverse of, matrix, find inverse of matrix A is equal to, say it is to be 1, 1, 1, 2, 3, 4, 2, 3, 4, 3, 5, 12, 3, 5, 12. Find inverse of a matrix this by partitioning method. By partitioning method. Okay, so let us start with this. So the very first thing, as you can see here in this working rule, the very first thing says partition a given matrix in such a way that matrix P is non-singular. Okay, so in the solution of this problem you have to start like partitioning. Okay, so let A is equal to this, and I am making it partitioning like this. If you want, you can do some other partition also. The only criterion is it should be non-zero. Now as you can see here, this is my P, this is my Q, this is my R, and this is my S. Okay, now take the determinant of this P. What is my P? My P is 1, 1, 2, 3. So what is its determinant? 3 minus 2. What is 3 minus 2? 1. Okay, means my partitioning is well behaving. Okay, now let us write this let A is equal to this matrix 1, 1, 1, 2, 3, 4, 3, 5, 12. Okay, is same as I'm writing a block matrix P, Q, R, S. Okay, where what is P? P is equal to matrix P is 1, 1, 2, 3. What is Q? Matrix Q is this 3, 5. What is matrix R? Matrix R is this 1, 4. And what is matrix S? Matrix S is 1 by 1 matrix having an element 12. Okay, now as you can see, this matrix P is a non-singular one because its determinant is not 0. So I can directly find out the P inverse. So what is P inverse? Now P inverse is equal to this. So what is my determinant? My determinant is 3 minus 2, that's 1. So it is like 1 upon 1 into adjoint. Do you remember the trick that I have told you earlier to find out the adjoint? What you have to do? Swap the diagonal elements. So here swapping gives you 3, 1 and give minus sign to the non-diagonal elements. Simple. So my P inverse is this 3 minus 2 minus 1, 1. Okay. Now the second thing is T. So we have to compute T. So let me rub this first. So now T is equal to our P inverse. T is equal to RP inverse. If you want, you can write let T is equal to RP inverse. What is my R? My R is this. So you can just write here 1, 4 and P just we have found out P inverse is 3 minus 1 minus 2, 1. Okay, now you can solve this. Once you solve this, what you'll be getting? First row first. Before I solve this, let me recollect you one of the basic thing. Matrix multiplication is possible if the number of column of the first matrix and the number of rows of the second matrix must be same. So this is 1 by 2, this is 2 by 2. So 2, 2. So matrix multiplication is possible. So what is it? This is 3 minus 4. So what is 3 minus 4? See here. This is 1 by 2. Its order is 1 by 2. Its order is 2 by 2. So as you can see here, its order is 1 by 2, order is 2 by 2. So this should match column of the first and row of the second. So it should match. Now as you can see, these are matching. So the resultant matrix will be of the order remaining 1 by 2. It is like this only. Okay. So what is the matrix multiplication? 3 minus 4 minus 1 minus 2 plus 4 is plus 2. So here I am getting this. Okay. Now next we compute W is equal to STQ inverse. Okay. So what is W is equal to STQ inverse? So what is W? W is equal to S. So I am making a bigger matrix. What is S? This 12. 1 by 1 matrix. 12 minus. What is T? T just we have found out. This is 1 minus 1, 2. What is Q in? What is Q? Q is this 3, 5. So this is 3, 5. And here it is. Its inverse. Okay. So it's inverse. So you can just find out these things. So this is 12. Now you can just solve this. So matrix multiplication is possible. So this is minus minus 3 plus 12. Minus 3 plus 12 is plus 7 inverse. So 12 minus 7 is 5. So I am getting 5 inverse, or you can write it as matrix 1 by 5. Okay, simple. Now next we have to compute Z. Computing Z is equal to minus WT. So what is minus? What is W? W we have just found out, that's minus of 1 by 1 matrix having element 1 by 5. What is T? T we have already found out, this minus 1 and 2. So multiplying this, so it will gives you its order is 1 by 1, its order is 1 by 2. So matrix multiplication is possible. Minus minus, this become plus. Minus minus become plus this. So this is minus minus plus 1 by 5, and this is minus 2 by 5. Clear? Now next we have to find out this. Y is equal to, next we have to find out this. So what we have to compute here? First we will compute this y is equal to q in this. Also y is equal to minus q inverse. What is it? Minus p inverse qw. Minus P inverse QW. So what is it? P inverse. So I am writing minus. What is my P inverse? This. So 3 minus 1 minus 2 1. This is P inverse. Then what is Q? Q is this 3 5 3 5, and then we have W. Just we have found out 1 by 5 minus 2 by 5. Simple. 1 5 minus 2 by 5. Correct. This is equal to. Now you can solve this first and then this. So I am taking this minus inside. So this is 3. Then minus 3, 2, 1, minus 1 into. Now multiply these two. So this is 3 by 5 minus 2 by 5. Sorry, 3 by 5 minus 3 by 5. First row, first column, minus 2 by 5, 3 2s are 6. First row, first column, 3 by 5. This order is 2 by 1. Its order is also 2 by 1. Sorry, this is 2 by 1. This is 2 by 1. Matrix multiplication is not possible. Just a minute. Just 2 by 1. This is also 2 by 1. Okay, so let me multiply these two first. So minus P inverse. So this Q is where it is, this one 3 5, and this W is, where is W? Yeah, here it is. W is 1 by 5. Sorry. So this is just 1 by 5. 1 by 1 matrix. Okay, now matrix multiplication is possible. So this is minus 3 plus 2 plus 1, and here it is minus 1. Okay, now you can multiply this. So if you multiply this should be 3 by 5, and this should be 1. Clear? This is 3 into 1 by 5, 3 by 5, and this is 1. Okay, so I hope rest of the thing is correct. Yeah, now you can just multiply this to get what is it, minus 3. So it is minus 9 plus 2. So this is 1 by 5 minus 9 by 5 plus 2. Yeah, so this is 1 by 5, and first row first column, second row second column. So this is 3 by 5 minus 5 by 5. So this is minus 2 by 5. So I am getting y. I am getting y to be 1 by 5 minus 2 by 5. Correct. Now after this y, what I have to compute? After y, we have to compute x, right? And what is the formula for x? I just x. Okay, next we have to find out x. X is equal to p inverse minus yt. So what is my p inverse? So this p inverse is equal to, where it is, p inverse, yeah, this one, 3 minus 2 minus 1 1 minus y. What is y? Just we have found out, it's 1 by 5, 2 by 5 with negative sign into t. What is my t? T, here it is, minus 1 and 2. This is t. Yeah, so just solving this. So this is 3 minus 2 minus 1 1 into, sorry, minus, here it is, first row first column. So first row first column will give you minus 1 by 5. Then the second row will give you 2 by 5, and then this will give you minus minus plus 2 by 5, and this is minus 4 by 5. So this comes out to be, so what is it? Now 3 minus 1 by 5, minus minus plus, so 3 plus 1 by 5, so this is 16 by 5. This is minus 2 and this is minus, so this minus 2 and this is minus 2, minus 2 by 5, so this is minus 12 by 5. Then we have minus and this minus, so it's minus 1 minus 2 by 5, minus 1 minus 2 by 5, this is minus 7 by 5, right? And then we have 1 minus 4 by 1 plus 4 by 5, 1 plus 4 by 5, so this is 9 by 5. So I am getting it to be like this. I hope this is correct. So this is 16 minus 12 minus 7 and 9. So after getting the values of this x, y, x, where it is, yeah, x, y, z and w, now you can write down the required inverse. Okay, so after this you just write down one sentence. The required inverse is very simple computation is there in this matrices, in this method. So you just need to write, therefore the required inverse is, A inverse is equal to, what is it? X, Y, Z, W, right? X, Y, Z and W. That is you can write A inverse is equal to X, Y, Z, W. So what is X? A inverse is equal to X. What is X? This. So this is 16 by 5, then minus 12 by 5, then minus 7 by 5, then 9 by 5. Okay, this is my X. Then what is Y? Y is this. Y is 1 by 5 minus 2 by 5. Okay, x, y, then z. What is z? Z is this. Yeah, it's not correct. It should be, because this is just the multiplication. So this is 1 by 5, yeah, plus 1 by 5 and minus 2 by 5. Yeah. Okay, that's z. We haven't used it, okay, anywhere. So it's correct. So my xyz, my z is 1 by 5 and minus 2 by 5, okay, and at last w is 1 by 5. Okay, what you can do at the most here, it is you can do one thing, like you can take 5 common and write down the inverse once more. This answer is also acceptable, so this is the required inverse. So I hope the method that we have discussed in this learning video are understandable, and if you have any queries you can contact. Apart from that, in the very next learning video we are going to take a problem of the same topic, that is inverse of a matrix by partitioning method. Only thing is, instead of a 3 by 3 matrix, there would be a matrix of order 4. Okay, so thank you for watching this learning video and enjoy learning mathematics. Thank you.